Good day, class. You are welcome to this lesson. Last time, we had a class on writing set notations into ordinary English, and I emphasized on the fact that you must avoid the use of technical words such as union, intersection, subset, empty set, cardinal number, and so on. Today we are going to look at calculations involving cardinalities. So we are given any two sets. Let's say the set A and the set B. The first thing is that the cardinal number of A union B will be the same as the cardinal number of A plus the cardinal number of B minus the cardinal number of A intersection B. So that's a case where the sets A and B intersect. So if the set A and the set B do not intersect, we say A and B are disjoint, and that will lead us to the second relation. The cardinal number of A union B, when A and B are disjoint, will be cardinal number of A plus cardinal number of B. If A intersection B is an empty set. Also, the complement of A union B is the same as A complement intersection B complement. And the complement of A intersection B is equivalent to A complement union B complement. Let's get some examples now. Example 1. Given that the cardinal number of A union B is equal to 20, the cardinal number of A is equal to 10, and the cardinal number of A intersection B equals 6. Find the cardinal number of B. So look at the question carefully. So this one is simply direct substitution into the first formula given above. So let's solve the problem. Quoting that formula, we simply have cardinal number of A union B is equal to the cardinal number of A plus the cardinal number of B minus the cardinal number of A intersection B. But in the question, the cardinal number of A union B is 20. So 20 is equal to the cardinal number of A, which is 10, plus cardinal number of B minus 6. Since 6 is the cardinal number of A intersection B. Now 10 and negative 6 are like terms on the right hand side. So 10 minus 6 will give 4. So that will give 20 is equal to 4 plus cardinal of B. Our aim is to find the cardinal number of B, which means the cardinal number of B should be on one side of the equation below. So we write 20 and 4 on one side. So writing 4 to the left hand side of the equation, we change the sign to negative. So that will give 20 minus 4 is equal to cardinal number of B, which implies that the cardinal number of B is equal to 16, since 20 minus 4 gives 16. So we have found our cardinal number of B. Let's look at the second example. Let's have a Venn diagram with these entries. So we have the universal set with two subsets P and Q, and the entries are in terms of Y and X. So the diagram represents the relationship among the set P Q universal set, and the cardinal number of P is equal to the cardinal number of Q, and the cardinal number of the universal set is equal to 50. So A, find the value of Y. B, find the cardinal number of P intersection Q complement. And C, find the value of X. So looking at that diagram carefully, you are given that the cardinal number of P is equal to the cardinal number of Q. Cardinal number of P simply means the sum of those entries within the circle of P. We add the entries because we are told that those entries are the cardinal numbers indicated. So let's solve that. So A, you are asked to find the value of Y. To find Y, we use what we are given. We are told that cardinal number of P equals cardinal number of Q. So looking at the circle for P, discover that the cardinal number within that circle for P, you have 2y minus 4, and that y within the region for intersection. So the cardinal number of P will simply be the sum of all the entries within the circle for P. Also, the cardinal number for Q will be the sum for the entries within the circle for Q, which is y plus 5. So we are now going to have 2y minus 4 plus y is equal to y plus 5. So the y's are like terms, while the figures are also like terms. So we add like terms together. So we add the y's together on the left hand side and on the right hand side of the equation. On the left hand side, 2y plus y will give 3y. y on the right hand side, y plus y will give 2y. So we are going to have 3y minus 4 equal 2y plus 5. But our aim is to find the value for y, which means the value for y should be on one side of the equation alone. So we write the quantities containing y on their own side of the equation, while all other quantities should be on the other side. So in this case, let us write the terms in y on the left hand side, which means 2y on the right hand side. We should write it on the left hand side. And let's write negative 4, which is on the left hand side to the right hand side. But remember, when writing quantity on the other side of the equation, the sign should be changed. So this will give us 2y subtracted from 3y is equal to 4 plus 5. Now, 3y minus 2y will give y, and 4 plus 5 gives 9. So our value for y is 9. The B part of the question, we are asked to find the cardinal number of P intersection Q complement. The cardinal number of P intersection Q complement. So looking at the diagram, P intersection Q complement is simply the region containing 2y minus 4. So since we have calculated the value for y, we simply replace that y by 9. So now we are going to have that equal to 2y minus 4. Replacing y by 9, we have 2 times 9 minus 4. 2 times 9 gives 18, so that gives 18 minus 4, which is equal to 14. The C part of the question, we are asked to find the value of x. We are going to use what was given. We are told in the question that the cardinal number of the universal set is 50, meaning that if we add everything within that circle and the region out of the circle, we should have 50. So everything within that rectangle should give 50 when added. So that means y minus 4 plus y plus y plus 5 plus x will be equal to 50. We add the y's together. 2y plus y plus y gives 4y. Negative 4 plus 5 gives 1. So we are going to have 4y plus 1 plus x equal 50. Then we know our value for y to be 9. So that gives 4 times 9 plus 1 plus x equal 50. 4 times 9 gives 36. So we have 36 plus 1 plus x equal 50. 36 plus 1 is 37. So you ask yourself, what can be added to 37 to have 50? So that value which can be added to 37 to have 50 is x. And that gives us x as 13. So x is 13. The third example. So given the sets F, G, and H defined as follows. F is simply the set of factors of 24. G is a set of factors of 20. H is a set of integers x such that 7 is less than x less than 12. A. List the elements of f, g, and h. B. State n of f. C. Represent f, g, and h in a Venn diagram. So look at those sets very well. I said you can define a set using the characteristic property or by listing the elements. The set f is given as factors of 24, but in A, you are asked to list the elements. So we have to list those factors of 24. And factors of 24 are simply numbers that you can divide 24 by without you having a remainder. And in H, you have integers, x, so that 7 should be less than 12. Integers are whole numbers, whether negative or positive. But in this case, you are given that those integers should be such that 7 is not part of it. So the integer should be between a number higher than 7 to a number less than 12. So you are asked to list that. So we are going to list that. So A, f is a set of factors of 24. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. The factors of 20 are 1, 2, 4, 5, 10, and 20. So the set H, those integers will be 8, 9, 10, and 11. So that is done with A. B, we are asked to give the cardinal number of f, and I said the cardinal number is simply the number of elements in a set. So to know the cardinal number of f, you simply count the number of elements in the set f, and that will give you 8. So when you're writing the cardinal number, that cardinal number should not be enclosed in curly brackets because a cardinal number is not a set. C, for us to draw the Venn diagram, we discover that we have 3 sets F, G, and H. So we need to know whether the sets intersect. The first thing is we look for the intersection of those 3 sets, F, G, and H. So F intersection G intersection H. We look at those elements, discover that there are no elements found in all 3 sets. Therefore, that intersection is an empty set. We now take them in pairs. Take from above F and G. Cardinal number of F is 8. Now look for the elements F and G. Discover that 1, 2, 4 are elements found in F and also found in G. So that forms the intersection of F and G. So you have the elements 1, 2, 4 as elements of the intersection of F and G. Take the next, which is F and H. Discover that you have 8 common to the set F and to H. So the element there is 8. Now take G and H. Look at the set G and H. Discover that 10 is common to both sets. Therefore, the element there is 10. Now we said to draw a Venn diagram, the universal set is represented using a rectangle. In this case, we have 3 sets, F, G, and H. draw the Venn diagram, we start with the intersection of all three sets. So look at F intersection G intersection H is an empty set, meaning that no element will be written in that region. We take the next, which is F intersection G. You see that we have 1, 2, 4. So in the region for F and G, look how the circles cut through each other. Seeing there are no element in the intersection of all three sets, 1, 2, 4, 4 in that region, shown in the diagram. Now take the next, which is F intersection H. Discover that we have 8 as an element. So that 8 falls in that region. So that region which is bearing 8 is simply F intersection H only. We now take the region for G intersection H. Discover that you have the element 10. So that 10 falls in that region. Now we take each set. Look at the set F. The set F. And looking at the Venn diagram, for the set F, we have already written 1, 2, 4, and 8 within that circle for F. Therefore, the remaining values, which are 3, 6, 12, and 24, should fall in this region. And taking the set G, discover that we have already written the values 1, 2, 4, 10 in that circle. So the remaining values 5 and 20 falls in the region for G only in order to complete the elements of G. And now looking at the set H and seeing the Venn diagram, we have already filled in the elements 8 and 10. So the remaining elements 9 and 11 fall in the region for H only. So our Venn diagram is now clearly drawn. See you in the next class. Till then,